Good morning, students. Welcome to the mathematics session. In the previous class, we had solved 3 problems on Thales theorem. From exercise 2.2, 3 problems were solved. Today I am going to show how to solve the 4th problem. In the figure ABC, DE is parallel to AC and DF is parallel to AE. Then we have to prove that these two ratios are equal. BF by FE, BF by FE is equal to BE by EC. These ratios are equal. That's what we have to prove. Then I said, whenever you find any parallel side to a triangle, we have to apply Thales theorem. We shall identify triangles. Here we can identify 2 triangles which has the parallel sides. In triangle ABE, can you see in this triangle ABE, in this triangle, I hope you understood, ABE triangle, which is the parallel side, ABE triangle, which is the parallel side, DF is parallel to AE. See, in triangle ABE, DF is parallel to AE. That's what I have written. In triangle ABE, DF is parallel to AE. And as we all know, in Thales theorem, if a line is drawn parallel to any side of a triangle, then it divides the other 2 sides in the same ratio. So it has to divide the sides in the same ratio. Which is the ratio here? BF by FE. These 2 sides are divided in the equal ratio. BD by AD. That's what I have shown. BF by FE is equal to BD by AD. Call this as equation 1, and the reason is basic proportionality theorem. So we have identified a triangle and a parallel side to one of the sides of the triangle and applied Thales theorem. Now we shall identify another triangle, which is the another triangle ABC, given triangle. In the given triangle, which are the parallel sides? DE is parallel to AC. In the given triangle ABC, DE is parallel to AC. Again we have to apply basic proportionality theorem, which are the sides divided BC and AB. How to write the ratio? You cannot consider F. We have taken ABC. BE by EC. See, BE by EC is equal to BD by AD. BE by EC is equal to BD by AD according to basic proportionality theorem, and call this as equation 2. Now compare 1 and 2. BF by FE ratio is equal to BD by AD. In the same way, BE by EC is also equal to BD by AD. Things which are equal to same things are equal to one another. Therefore, from 1 and 2, BF by FE is equal to BE by EC. This is what we have to prove. Again, we shall continue the next problem, children. 5th one. In the figure, observe the figure carefully. In the figure, PQR, DE, can you see? DE is parallel to OQ. Figure is given in the textbook. And DF is parallel to OR. This is given. What we have to prove is EF is parallel to QR. I have to prove EF is parallel to QR. If I have to show that the line is parallel to the third side, then I have to show that it divides the other 2 sides in the equal ratio. This is converse of basic proportionality theorem. But 2 triangles have got a parallel line to a side of a triangle. Let us identify those 2 triangles, apply basic proportionality theorem. Now let me consider triangle by OD. See this triangle, these sides are parallel. These two sides are divided in equal ratio. PE by PQ is equal to PD by DO. Call this as equation 1. In the same way, we can consider another triangle where we have the parallel sides, that is POR. Can you see, children? POR. In this triangle, DF is parallel to OQ. DF is parallel to OQ. If DF is parallel to OQ, again we can say that we can apply Thales theorem and write other two sides are divided in the same ratio. That is PD by DO is equal to PF by FR according to Thales theorem. When you apply these two, automatically you can identify EF is parallel to QR because other two sides are divided in the same ratio. To prove that, I start. What I have to prove? EF is parallel to QR. Has to be proved. In proof, we shall apply Thales theorem to two triangles, that is POQ for one triangle and POR is another triangle. In triangle POQ, which are parallel sides, EDE is parallel to QO or OQ. When a side is parallel to the other side, the other two sides are divided in the same ratio. PE by EQ is equal to PD by DO. Call this as 1. Reason is basic proportionality here. The same way consider another triangle. In triangle POR, which are parallel. TF parallel to OQ, OR. DF is parallel to OR. Then other two sides are divided in equal ratio. PD by DO is equal to PF by FR. Call this as equation 2. Reason is basic proportionality theorem. I hope you understood how to apply Thales theorem. Now compare equation 1 and 2. PE by EQ is equal to PD by DO and PF by FR is equal to PD by DO. Things which are equal to same things are equal to one another. Therefore, these two ratios are equal. Therefore, from 1 and 2, PD by DO and PD by DO are equal to both the ratios PE by EQ and PF by FR. Therefore, PE by EQ is equal to PF by FR. Now you refer this figure. PE by EQ. This ratio is equal to PF by FR. The ratios are equal, then it should be this line EF must be equal to QR. If a line divides the other two sides in the same ratio, then the line must be parallel to the third side. This is what converse of Thales theorem states. Therefore, EF must be parallel to QR. Reason is converse of basic proportionality theorem. Here there is a sixth problem, children, which is of the same kind. I'll just explain and you have to try to solve by yourself. Here is a triangle PQR in the figure. A, B, C. These are the points on PO, OQ and OR. A, B, C are the points which lie on PO, OQ and OR. They are joined in such a way that AB is parallel to PQ and AC is parallel to PR. This is given in the figure, but we have to prove that BC is parallel to QR. It is similar to the problem which we had solved in the previous one. We have to go for converse of Thales theorem. Before that, we have to identify two triangles. Which are the two triangles where I can apply Thales theorem? Can you see? This is POQ. This is one triangle. POQ. Which are the parallel sides? AB parallel to PQ. Then apply Thales theorem and call that as equation 1. In the same way, POR is another triangle where AC is parallel to PR. Apply Thales theorem and call it as equation 2. Again, you will find two ratios are equal to the same ratio. Using axiom 1, you can bring it to the other two ratios are equal. But when the other two ratios are equal, naturally BC must be parallel to QR according to converse of basic proportionality theorem. Children, this is quite simple as we had done in the previous one. Try. If you don't get, I will do it and show it to you in the class. I want you to do all the problems whatever it is taught in the notes directly, children. Thank you. Have a nice day.